Previously, we have discussed the set of real numbers, which is essential in studying algebra. Today, we are going to discuss integer exponent and understand the rules in performing calculations. By definition, exponent is a number that tells how many times a factor is repeated in a product. For example, 2 raised to the power of 4, meaning 2 will be multiplied 4 times to itself. Therefore, 2 raised to 4 is equivalent to 16. 2 is called the base and 4 is the exponent. We should always keep this in mind when doing calculation the different rules in mathematics, like the MDAS rule, which is very common to us. Now, you will learn the different integer exponent rules. First, we have the product rule. A raised to m times a raised to n is equal to a raised to m plus n, where m and n are integers. Therefore, when multiplying similar bases or like bases, in this case we have a, we add the exponents. Next integer exponent rule is the quotient rule. For any non-zero number a and any integers m and n, a raised to m over a raised to n, or this can be written as a raised to m minus n. When we divide like bases, we subtract the exponents. Notice also that the term in the denominator can be written in the numerator by changing the sign of its exponent. Another integer exponent rule is the power rule. For any integers m and n, such as a raised to m multiplied to n, is equal to a raised to m n. When we raise the power to another power, we multiply the exponents. How about when the two bases are raised to an exponent, such as ab raised to m? That will be equal to a raised to m multiplied to b raised to m. When we have a product raised to a power, we raise each factor to the power. Another power rule is when we have a quotient raised to a power. We raise both the numerator and the denominator to the power, such as a raised to m over b raised to m. Next is the zero exponent rule. For any non-zero real number a, such as a raised to 0, is equal to 1. So any non-zero real number raised to 0 is always equal to 1. Lastly, the negative exponents. For any non-zero real number a and any integer m, such as a raised to negative n is equal to 1 over a raised to n, notice that we can make the negative exponent to the positive by changing its position from numerator to the denominator, or denominator to numerator. Same as true when we have a raised to negative m over b raised to negative n. By changing the term from numerator to the denominator and denominator to the numerator, we have changed the sign of its exponent. Therefore, it can be written as b raised to n over a raised to m. How about the term in a fractional form, such as a over b raised to negative m? We can just reciprocate the term and change the sign of the negative exponent to positive. Now let us have an exercise to apply the rules in the integer exponent. Use a combination of the exponent rules to simplify expression. Write answer with only positive exponents. Assume all variables represent non-zero real numbers. Number 1, 1 over 2 x raised to 4 times 16x raised to 5. First, let us combine similar terms. Next, we multiply its coefficient which is 1/2, and 16, which is equal to 8. Since both terms has a variable x or same bases, so we can just copy the base and add the exponent. So therefore, 1/2 x raised to 4 times 16x raised to 5 is equal to 8x raised to 9. Number 2, 1/6 a raised to 5 times negative 3a raised to 2 times 4a raised to 7. Again, combining like terms, then multiply the coefficient. So we have 1/6 times negative 3 times 4. And then we have same variable, which is a. So we combine a raised to 5, a raised to 2, and a raised to 7. So simplifying this equation, we'll have negative 12/6. So we have negative 3 times 4, that is negative 12. Then 6, copy 6 since there is no other denominator. So we have negative 12/6. Then we can just add the exponent of our variable. So therefore, our answer will be negative 2a raised to 14. Next, we have 2x cubed times 3x squared over x squared raised to 3. Again, first combining like terms, numerator to numerator and denominator to denominator. Then add its exponent since they have common variable. Notice that we can still simplify this by moving the denominator to the numerator. So it will become 6x raised to 5 minus 6. This is from the quotient rule. So simplifying it is equal now to 6x raised to negative 1. So to avoid negative exponent, we can move x raised to negative 1 to our denominator. Therefore, our answer will be 6/x. That ends our discussion for the integer exponent.